All right, pre-calc, how are we doing? We are full swing online learning. I hope you guys are adjusting well. I know it's a confusing and crazy time right now for you guys, so please don't hesitate to reach out, email me if you need to set up a Zoom meeting to just get clarification. I'm here for you. I want to be available so we can meet face-to-face virtually to make sure we're all clear on what's going on. Just general things. We're going to be doing our lectures through Edpuzzle every week. We'll have a discussion post. Don't freak out about those. Those are going to be more of our emotional check-in, kind of how are we doing, what are we struggling with, things like that. They're not going to be like full-on real discussion post, okay? And then you'll have your Alex homework. We'll be doing quizzes, tests online. We'll introduce Flipgrid in a week or two. If we're going to continue throughout the rest of the year online, who knows what will happen at this point. But if we do that, we'll use Flipgrid a lot more. If we're going to come back after spring break, we might only use it once or twice. So don't freak out too much about that. It's just coming in the weeks to come. So how videos are going to work for notes is I'm going to partition them or make them into parts. So we're going to start with the intro video right now for 7.2. And then I'll probably have 1, 2, 3, 4 more videos. And each of those videos are different topics on Alex. Okay, so our intro, we have, oh, one more thing. I forgot to talk about attendance. And I don't really know if I'm supposed to talk about attendance with you guys or not. But how attendance is working is I have to take attendance for you guys every Friday and every Tuesday. And so how I will do it is all of our discussion posts are purposely due on Friday. So you do your discussion post, you are counted present for the Friday attendance. Say you forget to do your discussion post, it comes in late, It's not that big of a deal if I put absent. It's not gonna go towards any sort of like attendance awards or anything. You're not getting in trouble if you get an absent on a Friday, but you're present in everything else. For like an absent with a pre-calc, but present in everything else. The reason why they're taking attendance is to like check those kids that aren't participating and aren't keeping up in all of their online homework, and then they're gonna set up meetings and things like that. So Friday will be the discussion post, and then Tuesday will be, did you do the lecture through Edpuzzle? And so as long as you did your discussion post by Friday, you'll be counted present, and you did your lecture through Edpuzzle by Tuesday, you'll be counted present. And so if you have questions on how attendance works, email me, Zoom conference, anything like that. Just ask questions because I know it's kind of weird. Everything's different. But anyway, so intro to conics, okay? We are going to do parabolas today, and I will also put up a link to show you how those conics come out of the cone. I totally forgot to show you guys that last class. The definition of a parabola is a really, really fun one. It's a lot like a circle. Because it has that special equidistant word and all of that, all set of all points, things like that. Okay, so the definition is the set of all points in a plane that are equidistant from a fixed line as they are from a fixed point. Okay, and the key thing is that point is not on the line. So it's a set of all points in a plane that are equidistant from a fixed line as they are from a fixed point. So what this is going to look like is here's this line, and we're going to have a very special name for that line, okay? And we're going to call this the point, okay? And so it's a set of all points that are the same distance, okay? So for it to be the same distance between this line and this point, it would need to be right in the middle of that, right? Okay, and then go out, right? And so the distance from here to here needs to be the same distance from here to here, so it'd be something like that. Same thing. I'm not the best at eyeballing. Okay, and if you were to actually calculate, what would happen is it'd start to look something like this. And so from all these points, it is the same distance from there down to the line. Obviously, I'm not good at drawing this picture, If you want to watch the Khan Academy video on this, he does a great job of showing this, okay? And hopefully you can tell this is starting to turn into our famous U shape or a parabola. All right, so that's the official definition, the set of all points in a plane that are equidistant from the fixed line and from the fixed point. Okay, we have very, very special names though. So we don't call it a fixed line, we call it a directrix. And now that you're home alone, you can practice saying these things out loud. Directrix, okay? And that fixed point, yeah, we don't call it a fixed point either. We call that guy a focus. Okay, so I have a directrix and I have a focus. All right? And so the distance, the parabola is the distance, same distance to the directrix as it is to the focus. All right? And so I'm going to talk about what all of this is represented in the equation. So there are technically two different equations for a parabola. Because so far in your math time, you've learned a parabola is facing upwards and parabola is facing downwards. But now we're going to talk about parabolas to the left and also to the right, if I can get my hand out of there. Okay? And so there's two sets of equations. All right, so the first one is a vertical axis of symmetry. And then I'm going to come down here. And then we also have a horizontal axis of symmetry. All right, here's a key thing. This one, hopefully you remember from algebra, axis of symmetry is the middle of the parabola that I could just like reflect my parabola over and it'd line up perfectly. Okay, so when it's facing up and down, we would always have a vertical axis of symmetry. That is my axis of symmetry right there. Okay, which means if your axis of symmetry is vertical, your directrix is going to be horizontal. So if you want to take that into account, vertical axis of symmetry, but it'd be a horizontal directrix. Okay, and then same thing when I flip it and it's sideways, it's going to be a horizontal axis of symmetry, but then the directrix will be vertical. All right, so I'll start with the vertical one. Its equation looks like this. X minus h squared equals 4py minus k. All right, if you're going to do the horizontal axis of symmetry, that's y minus k squared equals 4p x minus h. All right, so how to remember what direction it's going where? Okay, the way I'm going to remember it, and the way maybe that will help you, is when the x is squared, that's like my normal parabola. Because when you think of a normal parabola, and I'm doing this off to the side so you don't need to put this on the same sheet of paper, okay, when you're doing, ooh, got all kinds of weird papers there. Okay, when you think of a normal parabola, we think of this or we think of this. Okay, and this is the equation y equals x squared, and this is the equation y equals a negative x squared. So when the x mess is squared, it's the normal parabola, it goes up or down. But over here, when the y is squared, that's the weird parabola, okay? And so that's going to be, this is going to be y squared equals x. Actually, that's left, so it's negative. And if we're going to do the right one, that's going to be y squared equals a positive x. All right, so hopefully that's kind of helping you. When x is squared, it's like what we've always learned, up or down. When the y is squared, it's something new. We haven't really talked about that, okay? And that's when we're doing the left and the right. Theoretically, you can still graph this on a graphing calculator. You don't have a y squared button. What you have, actually you couldn't graph that one because you have a negative. You could graph this one though, okay? You could do y equals the square root of x and y equals the negative square root of x. And it will actually graph that graph for you, right? And all I'm doing is square rooting and I have my plus or minus. Okay, so that's all where that's coming from, and it's going to graph that left thing. Okay, so those are our equations for our parabolas. Obviously, there's some very important things here. The first one is h and k. That's our normal normal mess, okay? So H comma K is your vertex. That has been your vertex since you did Algebra 1 with a parabola. All right, be very careful. Notice H is over here, but H is over here on this one. Okay, H goes with X because it's the X value of the vertex. And K goes with Y because it's the K value of the vertex. Okay, the next key thing is the absolute value of P. Okay, so the absolute value of P is the distance from the vertex to either the focus or directrix. Okay, so think about that. Up here, remember the definition is that it's the same, it's a set of points that is the same distance to the focus and to the directrix. So this little mess right here is P, and this little mess right here is P. Okay, it's that distance, all right? Now, the key thing is determining when P is going to be positive versus negative, all right? Because if it's positive, it's going to open positively. So how do you think of positive? Most of you would think upward, right? Upward's positive. What's another direction that's also positive, though? Take 10 seconds, think about that. It would be to the right, okay? To the right is also positive. Up and to the right is positive. But then think, what about negative? So what are some places where it'd be negative? Well, that would be a downward or to the left, all right? So what you need to know is when my P value is positive, okay, it opens up or to the right. And when my P value is negative, it opens down or to the left. All right, so looking at our equation, in both of these, your H and your K, that's going to be your vertex. The P is the distance from that vertex to my focus or my directrix. And whether this 4P, this stuff out in front right here, is positive, if it's positive, we know it's up or to the right. And then just depending on what equation you're in would say which one it is. And if it's negative, right, this mess is negative, then it's going to open down or to the left. All right, so that's just our intro video, and then we'll have 4 more examples after that. So just take a couple minute breaks, relax your brain, and then start on the next video.